start our week 2 question review session. So the quiz, again, the quiz and exam questions will be multiple choices or true or false questions. But in this question review slides, I'm directly giving out the answer just for simplicity. Okay, so yeah, let's get started. So for the first question, the question is asking when an atom loses or gains an electron, the resulting particle is called. So this is something we discussed, right, yesterday, if you still remember. When an atom itself is a neutral, when the atom loses electron, it will become what we call a cation, right? But when an atom gains electron, it will become what we call the anion. So cation and anion are the ions. Okay, so the answer for the first question, cation and anion. Okay, now let's see the second question. Second question is asking how many electrons are there in this bromine minus and in this bromine plus ion, and also how many protons and electrons are present in oxygen 2 minus. So how do we solve a question like this? Again, we will need some help from our best friend, which is a periodic table. So first, we need to go to our periodic table and find out the position or the sequence number of the element that is given, because we know the sequence number equals the atomic number equals the proton number, right? This is something we have discussed. So we first find out where is bromine. Bromine in the periodic table, we find it is number 35 is here. Okay, it means for the bromine, it has 35 proton. Okay, so for a neutral molecule, we know the number of proton is equal to number of electron. So which means at neutral state, bromine have 35 proton. But for bromine minus, since it is a anion, it means it gain more electron. So for bromine minus, it will get 35 plus 1, which is 36 electron. But for the bromine plus, it will be 35 minus 1, which is 34. Okay, so we are applying the same strategy for finding out the electron and proton for O2 minus. So we know for the O2 minus, the proton number for O2 is 8. So that's why the electron number for for a neutral oxygen is 8. But here it is asking the O2. So for O2, the proton number doesn't change. So the proton is 8. But for the electron, because it gained more 2 electrons, so in total it got 10. Okay, that is how we solve the question number 2. Question number 3. This question is asking to identify an element that is a nonmetal, a gas, and has an elemental symbol that starts with the letter A. So first, let's see where could we find the element that is nonmetal. From the periodic table that is provided, we know for the nonmetal, it is in this green region. Okay, it is in this green region. And also, it's asking, it's saying it is a gas. So which column represent it is a gas? This column, because we know for this column it's called the noble gas, right? And start with the letter A. Let's see which element start with letter A. Oh, I got it. It's argon. So the answer for the question number 3 is argon. Number 4. There's a very little of the element, this one, astatine on Earth. If astatine form an ion, it would mostly likely to have the charge of So don't get afraid when you see an element that you have never seen before. The element was given must be something like located in the periodic table. So we just need to go to our periodic table to find out at which column does this element stays in. Okay, AT, we eventually find out the element is here, number 85. Okay, and we know in the periodic table, the element at the same column will have the very similar chemical and physical properties. So therefore, we can say that for this AT, it will have very similar property as a fluorine, as a chlorine, or as a bromine. And for the fluorine, chlorine, and bromine, we have discussed a lot. So for this element, they tend to form a -1 charged anion, right? Because this column is called the halogen. So based on this train, we can say the this new element we have never seen before is most likely to have the charge of -1. Okay. Okay. Next question. An atom of a carbon-14 isotope would contain carbon-14. Again, isotope. The definition of isotope is something have it's the same type of element but have different numbers of neutron. So for the carbon-16, we know for carbon-16 it definitely have same number of it definitely have this like the 8 proton. Why it have 8 proton? Sorry, my bad. Carbon-14 definitely have 6 proton. Why it has 6 proton? Because its sequence number is 4, is 6, right? So for the neutral state of any element, the number of electron will same as the number of proton. So it will also have the 6 electron. So how many neutron can we say for the carbon-14? Because we know this 14 represents a mass number, and the mass number equals to the number of proton uh, plus the number of neutron. So since there are 6 proton within carbon-14, the number of neutron definitely will be 14 minus 6, which will be 8. Okay, now let's see the next question. How many neutrons are there in neon 22? So this is very similar to the previous question. For the neon 22, we know 22 is a mass number, which equals to the sum of the proton number plus the neutron number. So the proton number is where we can find directly from the periodic table. The neon is here, is element number 10, so which means the neon have 10 proton. Okay, so that's why for the neutron, there must be 12. Another question. What is the charge on an ion that has an atomic number 24 and contains 22 electrons? So in this question, the atomic number is given. We know the atomic number represents the sequence number, right? Which means the atomic number, this element have the number of proton of 24. Okay, so the proton is 24, which means in total there are 24 positive charge. So the number of electrons is also given. The number of electron is 22, which means there are 22 negative charge. Therefore, in total, the net charge for this element will be plus 2. Okay. Next question. What is the oxygen to hydrogen mass ratio for H2O? Okay, for H2O, we know within one H2O molecule, there will be 2 hydrogen and 1 oxygen. So how do we find the mass of the hydrogen? The mass of the hydrogen is something we can directly read from the periodic table. If you go to your periodic table, you'll find the mass of the hydrogen will be 1. Okay, so 2 times 1 will give you 2. For the oxygen, we can also directly read from the periodic table. It's 16.00. So therefore, the mass between the hydrogen and the oxygen will be 2 to 16 or 1 to 8. Next question. When elements combine to form a compound, their property change completely. Remember the example that was given during our class. The sodium, when it is in elemental state, it is a very reactive element. And for the chlorine, when it is in elemental state, it is a very reactive gas and toxic gas. But when sodium react with the chlorine, it will generate the sodium chloride, which is a table salt we eat every day, and it is completely non-toxic. That is why when elements combine to form the compound, their property change completely. Okay, next question. The carbon to hydrogen mass ratio is 3.0 for a compound. So this ratio could correspond to the compound of which one? CH2 or CH3 or CH4. So now let's try to calculate one by one. For CH2, we know for one molecule within CH2, it contains 1 carbon and 2 hydrogen. The mass for 1 carbon is 12, which we can read from periodic table, and the mass from the 2 hydrogen is to multiply 1, which give you 2. So their mass ratio is 6.0. Okay. For CH3, we're applying the same calculation, 1 carbon, 3 hydrogen, which is 12 over 3, which will give us 4.0. Okay. So therefore, we can rule out the CH2 and CH3. Okay. Now, let's check CH4. The CH4, the mass for the carbon will be 12. The mass of this hydrogen will be 4. So therefore, their ratio is 3.0, which is the answer. Okay. Next question. Next question is asking how many each type of atom are there in the formula of this one. The first one, aluminum compound and the ammonia compound. For the first aluminum compound, let me write it down. So in this aluminum compound, there are um, there are 1 aluminum, 3 chlorine, and 9 oxygen. 9, we get 9 by 3 times 3. Okay, 3 times 3. For the next element, for the next compound, the ammonium compound. Okay, this compound, the number of nitrogen will be 2, and the number of hydrogen will be 4 times 2 plus 1. Okay, because here we got 8 hydrogen, and here we got 1 more hydrogen. So in total, there are 9 hydrogen. And for the phosphorus, we got just 1 phosphorus, and for the oxygen, we got 4 oxygen. Okay. Next question. What is the oxygen to sulfur mass ratio for the sulfur dioxide? So how do we calculate this question? Again, the number or again the name of the compound is provided. It is sulfur dioxide. Okay, sulfur dioxide. Based on the name, we can write down the chemical symbol, right? The chemical formula. The chemical formula will be sulfur dioxide because we have a prefix of di. It means there are 2 oxygen. So sulfur dioxide. So how do we calculate the ratio? Again, we need to rely on our periodic table and just directly read the mass for the sulfur. For 1 sulfur will be 32, And the mass for the one oxygen is 16. 16 because we have two oxygen, 16 times 2, we got 32. That is why the mass ratio between the sulfur and oxygen will be 32 to 32 or 1 to 1. Next question. Which metal atom below cannot form a cation of several different charges? So remember, within the periodic table, we separated it into like two parts. The part in here is called the transition element. Okay, so for the transition element, the reason why we are not covering the property of transition element is because element within this region tends to form multiple charges or have a very versatile charging state. That is why we can say any element within this region can form the cation of different charges. So with this as our background knowledge, we can check one by one. Okay, the first one, iron. Iron is in this region, so it definitely can form different charging state. Manganese is also here, and also chromium is also here, which means iron, manganese, and chromium can form different cation of different charging status. But for the last one, barium. Barium is our main group element. That is why the barium have only one charging state. So for this question, the correct answer is the last one, barium, Ba. Next question. The formula for this potassium chlorate is potassium KClO3, and the formula for this magnesium chloride is MgCl2. So what is the formula of the magnesium chlorate? Okay, let's check this question. Potassium chlorate is this. We know the charging state for the potassium is +1, which means the charging state for this chlorate polyatomic ion will be -1. Okay, and for the magnesium chloride, we know the magnesium have the characteristic charging state of +2 because it is in 2A group. That is why, okay, so now we can say what type of compound will be formed between a magnesium +2 and the chlorate -1. Remember how we solved this type of question? We just swap or we just change the position, right, of the charges. So the eventual or the compound that will be formulated with the charge neutral state will be magnesium chlorate with a parenthesis of 2. Okay. Next question. Next question is about the nomenclature questions. So what will be the name of this question of this compound? So the first one. First, we go to our periodic table and find out the Mn, the name for the Mn. Mn, the name of Mn is manganese. Okay. What about the S? The S is a simple uh, anion. So for the simple anion, we tend to give it a suffix of IDE. Okay, so this S is the sulfide. Okay, that is why for the first one it's manganese sulfide with IDE. Okay, manganese sulfide. Second one, CaCl2. This is simple. This is a calcium chloride. Why we call it chloride? Because again, chlorine is a simple element, is a simple anion. So we will add a suffix of IDE. So chlorine will become chloride. So uh, calcium chloride. Next one, magnesium. Magnesium what? NO3. So the for this polyatomic ion, their name will be provided as a chart. So NO3, its name is a nitrate. So we will call the third compound as magnesium nitrate. The next one, sodium nitride. Okay, sodium nitride. Next one, what is the name of SR? We don't know, but we can go to our periodic table. This is SR. Okay, the name of this SR will be strontium. Okay, so the name of this compound is the strontium carbonate. Strontium carbonate. Okay, last one, the next one, lithium sulfate. Okay, lithium sulfate. Lithium, the next one is called lithium sulfide. Sulfide. One is sulfate with a suffix of ate, another is with a suffix of ite. Okay, last one, the next one, sodium oxide. O, again, oxygen is a simple anion, so we give it a prefix suffix of ide, so oxygen becomes oxide. The last one, B represents boron, F represents fluorine, and in this case we call it fluoride. So it's boron fluoride. But pay extra attention here. Boron fluoride, because this one is a molecular compound. Because boron is a nonmetal and or like a metalloid, and fluorine is a nonmetal. So we call this the molecular compound. For this molecular compound, we need to give it a prefix to specify the number of uh, the type of the number of the atoms. So these three, therefore, are translated into tri. Okay, so the correct name for this compound will be boron trifluoride. Okay, uh, that is about the naming of the different chemical compound. The last question in this section. So what is the mass ratio of the sodium to sulfur in sodium sulfide? In sodium sulfide, for the sodium, it has a characteristic charge of +1. For the sulfide, it has a characteristic charge of -2. So the compound eventually will be formed will be sodium 2 sulfur. Okay, so how do we find the mass of sodium? Sodium, we can directly get the mass from periodic table, and the mass of the sodium is actually 23. So because we have 2 sodium here, it's 23 times 2, which give us the number of 46. Sulfur, we can also read from the periodic table. The mass of the sulfur is 32. Okay, so 46 divided by 32, we got the mass ratio of 1.43. Okay, that is something I have prepared for this question review slides for the week 2. I hope it is helpful for you to get prepared for your quiz. And thank you so much for your attention.